Question 3, solve the initial value problems. And if you look at the questions, uh, we we have the x, the y. That's a signal for you. Okay, this function, which one is it? M, which one is the n? Because this one, if you're looking at it now, it conforms to this form. Your dx is your m function as a function of two variables, okay? And then your n must have a dy, and also the functions of two variables. We're just told to solve the initial value problems. So when you have this kind of format now, this is exact method you can use to solve this question. And this is a first order differential equation. Okay, you can see the y and the x. Okay, so what do we do now? We have already spotted out what is m and what is n function. It's very important for you to be able to note or to know which one is m, which one is n. So in this case now, since I've known that the x will be m, then my m is what? I know my m, that is this plus this. Then differentiate this partially respect to the other function, the y, partially. Okay, and that will be equal to, when you are differentiating partially, the thing is very simple. If you have two functions, even three functions, just look for the function y and what, since it's respect to y, and differentiate that one alone. I'm only differentiating x and y alone here, which is 1. This is just a constant, so I have this. Here, there is no y here, so it's just a constant. And when you differentiate a constant, that's standalone. When you differentiate a constant, that's 0. Okay? Then, I know my n also. My n is what? My n is this also. This is my n. Then, do this one also partially. Differentiate this one partially respect to the other function, respect to x. Okay? And this is the only function I have that has x. So that's because of this. So these two differential is what is exact. That partial differential of m respect to y is equal to a partial differential of n respect to x. They are equal to each other. So this is what? This is exact. This is exact. And when an equation is exact, there is a way forward. You make a statement there, therefore, since it's exact, there is a function x and y such that there is a function x comma y such that partial differential of f respect to x, okay, equal to what? Respect to x will be equal to m, and m is what? Equal to m, okay, and my m is what? Y this plus this. Okay, and if you like also, since even a function is exact, there must exist two functions. This one that are f respect to partial differential of f respect to x must equal to m, and partial differential of f respect to y must equal to n. Okay, so you can use anyone to continue and get the solutions of the given given problem. So I think let's use this first one. Let's use this first one. Okay. So with this statement now, what you do is to integrate both sides partially with respect to x. So your f will now become integral of what? Integral of this plus this. Then you put your partial differential and then plus g of y. Okay, I've explained that. Once you are integrating respect to x, then your constant will be g of the next variable, g of y. And what we want to do now, this is our solution. Once you get the integral of this, and you can get your g of y, that's the solution. So the target now is to get g of y. So how do you do that? Let's see the steps to how to get g of y. So this will now become, this is respect to x. when you are doing partial integration, look for that function, look at that variable, look for that function. This one you have your x. So you're only integrating this one, you're keeping this one constant, and this will be equal to what? This. Here also you have x there, so plus what? Plus this. And that will give you g of what? G of y. That's your f. So it doesn't stop there because we have not gotten our g of y. So differentiate now partially. Differentiate partially with respect to y. Differentiate partially with respect to y, and that will be equal to the partial differential of f respect to y. It has a connotation. It has a symbol. This is theta f respect to y. Partial differential of f respect to y is n. Is n. Is n. Okay, and it has a value. The n is what? This is it here. Ex plus what? Ey. Okay. Equal to what? Differentiate this. So respect to y, keep this one constant, you differentiate this, and I have this. This one also. Do you have y here? We don't have. So that's 0 plus what? Plus g prime of y. When you differentiate this one, you have g prime of y. Okay, in this case now, something must cancel out. This is cancelled, this cancels, and I have g prime of y equal to what? E y. Okay, then integrate both sides. Integrate both sides respect to y, and that will be equal to what? G of y equal to integral of e of y dy. Okay, then whatever you get here, this will be ey and then plus c1. Then you now come back here and substitute for your g of y. So f is now become f is you come back here and substitute. So f is equal to this plus this, okay, plus ey plus c. Okay, and don't forget we have said that your c will be connoted as, your f will be connoted as what? Will be represented by c. Okay, so this one go to the other side. So c, bigger c minus c1 is c what? It's a c. So it's c. So your solution will now become the solution. The solution is this plus this plus ey equals to c. Then we have some initial value conditions. We have this one. There are some conditions here that when x is 1, y is also what? Y is also 1. Okay? When x is 1, y is 1. Y is 1. So just substitute that into this solution. X is 1, this is 1, this is 1. I have this plus this one also. I have E1. I have E1 here. I have E1 here plus E1. So that will give me 3E. Okay, equal to 6. So the solution is now y this plus this plus this equal to 3E. So that's the answer to that problem. That's the answer to that. Question 4. Find the value of k such that the following differential equation okay is exact. Okay, they've already told us that is exact. So what we just have to do is also follow the procedure. Which one is m? This will be our m, the functions of x and y, and this will be our n. It's also a functions of y. How did I know? Your m must follow with dx. Your n must follow with what? Dy. So let's do the beta m respect to y. Okay, so that will be what? 3y squared. Here it will be what? Plus 4k xy3. Okay, here there is no y here, so that's 0. Then the n, theta x. Okay, do that with respect to x. Okay, x is there. Okay, any other variable will be constant. That will be 3y squared. Then here also, any other variable will be constant except x. We are differentiating x squared, and that will be what? Plus what? That's 20x times this one. That's 40x y3. Okay, and then find the value of k such that the following differential equation is exact. It's already exact. They told us. Then that means that m that y must be equal to what? Must be equal to this. Let's do that. Now 3y squared plus 4k xy3 is equal to what? 3y squared plus 14x y3. Okay, this one and this one will cancel out. Then I can take k out here. K will be equal to 40x y cubed over 4 what? 4x y cubed. So 4y cubed is here cancel out. So the answer is what? K is 10 for this question. Okay, K is 10 for that question. So that starts. K is 10. Okay, K is 10. Just get your m. Get your delta m respect to y, get your partial differential of n respect to x, and then equate them together because the question has already said that the differential equation is exact. And that's just that. And when you are differentiating, I've told you that when you are differentiating partially respect to y, okay, look for that y. This is the only y here. That one is okay. But here it has a combination of two variables, x and y. Okay, that means the other variable will be kept constants and you differentiate the y. That's what we did. That's what I did. Here also, this is a respect to x. Your target is just x only. Differentiate x and the y variable will be kept constants. 3y squared will be kept constants. This one also differentiate x squared and then 20y cubed will be kept constant. That's that on that. Okay, we're still continuing on exact differential. We want to ensure that we have all necessary conditions. We have in-depth understanding on these topics. So if you are new on this channel, please hit notification bell. Hit that notification bell so that as we upload, you get notified. And also, you can also invite your friends and family to also join this channel so that they also can also be partaker of this channel. Thank you for doing that. Join me in my next video.